Let's start with a new question. Explain in terms of molecules why it is possible to compress a gas but not a liquid. Now, to understand this question, let's first understand the arrangement of molecules in a gas when compared to that of a liquid. In a gas, the molecules are very far apart. In a gas, the molecules are very far apart, and this particular reason helps us understand that it is easier to compress a gas than a liquid, because in a liquid, the molecules are comparatively spaced closer to each other when compared to that of a gas. In a liquid, the molecules are comparatively spaced closer to each other when compared to that of a gas. And this particular reason is because in a liquid, the intermolecular forces are slightly stronger than compared to that of a gas. And this is also the reason why it is easier to compress a gas, as the act of compression is just the act of bringing the molecules closer. Moving on, two containers made of insulating material contain the same volume of water at room temperature. The containers do not have lids. The volume of liquid in each container gradually decreases. After a certain time, the temperature of water has decreased to below room temperature. Explain in terms of molecules why the temperature has decreased. The reason why temperature has decreased is because the water molecules which were faster or which had a higher amount of energy in them started to evaporate, and this evaporation is further enhanced because the containers do not have lids. And because of this evaporation, the molecules which have a lesser energy or molecules which are slower remain within the liquid, or remain within the container which makes up the liquid. And this is the reason why the temperature has decreased below the room temperature. Moving on to the last part. One of the containers is wide and shallow. The other container is narrow and deep. Predict which container has a greater rate of cooling and explain your answer. The container which is wide and shallow has a greater rate of cooling when compared to the container which is narrow and deep, because the container which is wide and shallow has a greater surface area, a greater open surface area to be specific, a greater open surface area, which is responsible for a higher rate of evaporation.